Good morning, everybody. Today we're going to be talking about ellipses and then graphing them as and just parts of an ellipse. But let's just jump right into it. To do this, again, there's going to be multiple forms of this, and they're going to look really similar, but basically they're the exact same thing. The only difference is that the y and x switch, and this is because it depends on the orientation of the ellipse. But in these cases, A is greater than B. So basically, if you have the bigger number, the bigger denominator is going to be first in this scenario. But you don't. I mean, you could switch them around if you wanted to. You'll see me just keep x in the front often. Just remember that A is the bigger number between the two. And this will look like a lot like a circle. Ellipses look like circles in a way, just stretched. But A is going to be the distance between the center and the vertex. And there's two vertices and there's two co-vertices. So co-vertice is just the other kind of edge of the circle that we associate with the ellipse. It's just the shorter distance. So vertice is the long distance and co-vertice is the short distance. But since the bigger number is attached to A here, it'll be longer. And since A is attached to Y here, it'll be taller. Woof. Okay. Vertices, again, are the portions that are the further away. Co-vertices are these portions. That's vertices, co-vertices, and center. There are foci or focuses is the correct plural is foci, F-O-C-I, or foci. I hear it both ways. I think foci is technically correct, but I don't like that, so I'm going to say foci. So the foci are here, respectively, and they're along the major axis, which is just the axis that connects the vertices, and you find those by or C is the distance from the center to the focus, again along the major axis versus the minor axis. And you find that, careful, it's a squared minus b squared. You want to make sure that it's in between, it's inside of the ellipse. So if you did a squared plus b squared, it's going to be outside of the ellipse. But it doesn't, as long as you have that written down or memorized, you don't have to remember. It should work every single time. Just don't confuse it with a squared plus b squared. All right, to do these, you need to have a few things figured out. So a vertex is -4, 0. A focus is 3, 0. Its center is at the origin, or 0, 0. That is super important. You couldn't just do it with this because there are two different scenarios where this could work. This could be the closer focus or it could be the further focus from this vertex. So you need to take that into account. But I'm sure you wouldn't have done anything different, obviously. So it's centered at 0, 0. I'm going to just split this. And center. I'm just going to put everything down on the paper. It looks like I'm going to need to scale a little bit. So I'm going to scale everything by 2. So this is our vertex. Our focus is at 3, 0. Again, scaled at 2. The nice things about ellipses is that they're symmetrical. They're symmetrical across both of the minor and the major axis. The major axis being this, which just means that I can reflect everything over our minor axis to get other coordinates. You don't really need those to get the next part, but you do want that portion. Now the focus is C away from 0, 0. So C is equal to 3 because it's 3 away from 0, 0. and A is the distance away from the center to the vertex. So A is 4. So we need to solve for B to figure out that portion. B squared is equal to A squared minus C squared. And I got that from just rearranging C squared. I need to write up here. C squared equals A squared minus B squared. I just added B squared and subtracted C squared. So B is going to be the square root of that. A is 4, so B is equal to square root of 16 minus 9, which is 7. So the square root of B is the square root of 7. Okay, so square root of 7 is the distance away from the center going vertically. Square root of 7 is a little over 2. You don't have to be too exact here. Again, we did scale this by 2's, so it's about right here and about right here. We're just going to connect, and it should look something like that. But it also wants the equation. I'm going to erase some stuff to squeeze it in, but we should be good. So the form is x minus h squared. I don't need that parenthesis. X minus h squared. So x minus 0 squared is just x squared over 4 squared, or 16, plus y minus 0 squared over the square root of 7 squared is equal to 1. So that is our equation. All right, we have a focus at 0, 2, and we're going to use a scale of 1 here. So we'll focus is at 0, 2. Vertices are at 0, 3 and 0, negative 3. That tells us a few things right off the bat. They are centered at 0, so the center is going to be 0, 0 because these are going to be equidistant from the center, obviously. So the center is halfway between these 2 points. Halfway between those 2 points is right there. Also, this should be the same distance from the vertex to this vertex. So this should be a coordinate as well. Not as important to plot that one, but still nice to put down the foci into an ellipse. We can't get the co-vertices from this. We have enough information to find them, but we can't graph them yet. So to get there, again, we need to use this idea, but we know A is 3 because it's 3 away from 0, 0, and C is 2, 2. C is 2 because of that. 0, 2 is 2 away from 0, 0. So again, B is equal to the square root of A squared minus C squared. So B is 9 minus 4, or square root of 5. And then just throw it all in. So square root of 5 is a little over 2 again. So it's going to be right there and right there. A little closer to circular than the last one. Poorly drawn again, but you can handle it. Just throw it all in. Center's still 0, 0, so we're going to have, I'm going to play with the correct orientation according to your notes. So since A is attached to Y in this case, because it's moving, it's stretched vertically, it is y squared over 9 plus x squared over 5. And that equals 1. All right, the center's at 2, negative 3. Focus is at 3, negative 3. vertex is 5, -3. I'm going to just put that all on there and we'll go from there. I'm going to scale by 2 and still going to have... I'm going to cheat a little bit because I know stuff. But I think it'll be okay. So I'm going to move it like that just because I know that all of the action's happening over here. And if we do that, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If we do that, we shouldn't need to scale it besides 1 to 1. So I'm gonna leave it like that. Yeah, let's get into it. Okay. So graphing this, 2, -3 is our center. Focus is at 3, -3. And a vertex is at 5, -3. Okay. This is our center again. This is our vertex. It should be mapped across on the other side as well. So this is another focus, and this is another. Wait a second. My bad. Okay. Hey everybody, I can count 1, 2, 3, 4, 5. Okay. Back in business. Still there, and it's there. Okay. Just double checking. Yep, got it. All right, so A is the distance from here to here, or 1, 2, 3. So A is 3, and C is going to be 1, because it's the distance from the center to a focus. So 1, and B is the square root of 9 minus 1. So B is the square root of 8. Square root of 8 is just a little less than 3. So like right there. That's interesting. Let's see, like right there. Okay. Connecting. And this is probably the closest to a circle as you'll have between them because A and B are really close to each other. But it's stretched horizontally a little bit. It's centered at 2, -3, so we're going to have x minus 2 squared over a squared. And then we're going to have y plus 3 squared over square root of 8 squared, and equals 1. Okay. I'm actually going to skip this just for the sake of saving some time. If you need help on this question, feel free, but you're just, again, finding the equation of it based off the graph. You can find those co-vertices and vertices based off of the graph. It's not trying to trick you at all. It also gives you the center. Checking on your grapher is just solving for y. That can be tricky, but you can do it. If you get stuck, you can use Desmos too. And I'm just going to jump ahead to number 3 because that I think is the hardest part. And this is just putting it into standard form. So I'll start you off. If you divide everything, you want this to equal 1. Equals 1. So that means that this is our a squared. So it's stretched vertically. It should look like this, where that distance is 3, this distance is 1. After that, should be just tossing it, make sure you have the correct center and all that, but I'm not going to spend too much time talking about that one because this one is definitely the difficult part. And it's difficult because you have to complete the square twice. Right there may have scared you, but don't worry. The key is you want to get all of the x's together, and you want to get all of the y's together. and you want to get everything else, basically the constant, to the other side. That should be squared. And the next step is you want to factor these separately. So you want to factor out the coefficient, which is 2 for x squared. And you want to factor out the 3. And you are going to take half of this, square it, and then add that inside the parentheses. I'll show you what to do with that in a second, but you're going to add. So half of 4 is 2. 2 squared is 4. Half of 2 is 1. 1 squared is 1. Now you're not adding 4 and 1. You're going to be adding 2 times 4 and 3 times 1. Because if you were to distribute this, you wouldn't just have straight up 4. You'd have 2 times 4. So you're going to add 8, and you're going to add 3. So negative 5 plus 8 plus 3 is the right-hand side. That's kind of the hardest part to this. Well, we have 2 times x minus 2 squared plus 3 times y plus 1 squared. Negative 5 plus 8 is 3. 3 plus 3 is 6. Just making sure I have that right. Okay, 6. And you're then going to divide both. You're going to divide everything by 6 so that it can equal 1. 2 divided by 6 is a third. 3 divided by 6 is a half. And then you're just going to find the information based off of this. You already have the center because it's h and k. So our center is 2, negative 1. The next easiest part is the vertices, because we don't have to figure out what the c value is. But a is the square root of 3. I'll write b, but we don't really need to know b. B is the square root of 2. So our our vertices are root 3 away from 2, negative 1 horizontally. It's stretched horizontally, so you need to move left and right from the center. So our vertices, our verts, I'm going to cheat, but I'm going to say 2 plus or minus root 3, comma, negative 1. Ideally, you're going to write that separately, but it's just writing 2 different coordinates out. Next, our foci are going to be, so c squared is equal to a squared minus b squared, which is just taking these two numbers and subtracting. Right? This is a squared, this is b squared. So c squared is 3 minus 2, or 1. So c is 1. This is the distance away from the center, again along the major axis. So moving horizontally. This is the x-axis is our major axis. So the foci, and I'm not going to cheat on this one just because it's a nice number, but 2 try that again. 2 plus 1. 2 plus 1 is 3, comma, negative 1. The other one is moving the other direction, so 1, negative 1. But there's your information. You could graph all of this and you're good. The co-vertices are just taking these and adding and subtracting them to negative 1. But completing the square is obviously the hardest part of this. After that, you have your information to get there. But that is it for this one. We have one, maybe another. I have to decide on that, but we're getting close to the end. So keep strong, everyone. Keep doing what you're doing, and I'll see you on the next one.